like to try to keep the videos around 10 minutes. Those give me the size of files that I can work with pretty easily. So that's why each video ends around the 10-minute mark. I'll let it go as long as 12 minutes, but much above 12, my computer does not like doing that. So picking up with my limits at infinity here, the limit as x goes to 0. Okay, again, notice that it's kind of in two parts here. A part that I know what's going on easily, and a part that's going to take more work. So I'll split it up like this. This one we can do direct substitution, and we'll leave the next one for figuring out later. And so what that's going to give me 5/2 minus the limit as x goes to 0, 1 over x. And so now let's just concentrate on that 1 over x limit. So we're going to consider now the limit as x goes to 0, 1 over x. And so that's going to be 1 over 0. And again, non-zero over 0. So it's either going to be infinity or negative infinity or does not exist. With the does not exist, possible only for the two-sided. Now we've seen the two-sideds do not have to be does not exist. We did do an example where the two-sided turned out to be infinity. So don't get lulled into this idea that two-sideds are always does not exist. Now this one is going to turn out to be does not exist, but it doesn't have to be that way. I've got to do left and right, because it matters, left and right, what's going to happen to that 0 down there. That either that 0 is going to be very, very close to 0 but slightly negative, or very, very close to 0 and slightly positive. So left, the limit as x goes to 0 from the left of 1 over x will give me 1 over 0 from the left. Positive over a negative, so that's going to be negative infinity. From the right, that's the limit as x goes to 0 from the right. And that's going to give me infinity, because I have positive over positive. And the reason I get to conclude the infinity is because I have that non-zero over 0. You've got to show the non-zero over 0, because that is what justifies the infinity, or negative infinity as the case may be. So the two-sided, the limit as x goes to 0 of 1 over x does not exist, because the left did not equal the right. And so then answering the problem here, so we had this. We had the limit as x goes to 0 of x cubed plus 5 over 2 minus 1 over x. And then we said that that was 5/2 minus the limit as x goes to 0 of 1 over x. And then abusing notation here, that'd be 5/2 minus does not exist. Horrible abuse of notation here, but that's kind of the thought that's going through all our minds. Well, the 5/2 just doesn't matter. What overrides everything here is this guy does not exist. So that concludes our first types of limits involving infinity, where the answers come out to be infinity. And notice here, all these guys were approaching numbers. And when we approach our number, our first step is to substitute. And so we're going to go on in a minute to limits as we're not approaching numbers, but we have sort of concluded everything about, for now, everything about limits as x approaches a number. So kind of a summary of that. Summary of limits when x approaches a number of non-piecewise defined functions. Piecewise defined functions we did discuss, so you'll have to go back and look at those a little separately if you want to review that. But if it's a non-piecewise defined function and it's a number, the first thing you do, you substitute. If a real number results, that is your answer. Remember, 0 over non-zero equals 0, and 0 is a real number. I will have students, when the answer is 0, tell me that the limit doesn't exist. And you're probably guaranteed that I will give you a test or quiz question where the answer is 0, and someone will tell me that means that the limit doesn't exist, and I will take away all the points. 0 is a perfectly good number. It's cases of 0 over 0 that are more special. If substitution yields 0 over 0, try one of the following. Factor, cancel, substitute. Rationalize as appropriate. Simplify, cancel, substitute. If the above don't work, try simplifying if possible. See if that helps. If it's a trig limit, try techniques for trig limits. But very important to remember, 0 over 0 as a limit tells you nothing other than to try something else. Now, some of you know something called L'Hopital's rule, and we will get to that, but you cannot use L'Hopital's rule till we get to L'Hopital's rule. So yeah, there's this easier way for some limits called L'Hopital's rule that is not available for your use till we get there. For now, 0 over 0, that you want to do one of those things. If substitution yields non-zero over 0, the answer is either infinity, negative infinity, or does not exist. Be sure to use left and right limits where necessary. So the point here is when you have a non-piecewise defined function and it's approaching a number, substitution tells you which way to go. If you substitute and get a number, you're done. If you substitute and get 0 over 0, you're going to try one of these things until we learn something called L'Hopital's rule, but you can't use L'Hopital's rule until we get there. If you substitute and get non-zero over 0, you do the analysis to determine if it's infinity, negative infinity, or does not exist. Okay, the last type of limits we need to discuss. Limits at infinity. That's where x approaches infinity or x approaches negative infinity. So consider the limit as x goes to infinity of 1 over x, and the limit as x goes to negative infinity of 1 over x. Note here, x is not approaching a number, so substitution is not possible. Infinity and negative infinity are not numbers and may not be treated as numbers. Infinity is the concept of increasing without bound, and negative infinity is the concept of decreasing without bound. Or that is the idea of getting bigger and bigger and bigger without stopping, or getting smaller and smaller and smaller without stopping. To investigate the limits, let's make some t-charts. So I have 1 over x, and I'm going to plug in there 1 divided by 1 divided by 100, and I get 0.01. Do the same thing for 1,000, I get 0.001, and for 10,000, 0.0001. Based on the chart, and you can kind of think that that's going to continue, based on the chart, I'm going to get more and more zeros, and so it's 0.00000000001 eventually. These keep coming closer and closer to 0, and so I'm going to imply that the limit as x goes to infinity of 1 over x is 0. Then over in the next chart, same thing, but they're going to be negative. And again, my y values, my functional values are coming closer and closer and closer to 0. They're slightly negative this time, but they're coming closer and closer to 0. So I can conclude that the limit as x goes to negative infinity of 1 over x is 0. And there's my graph, and I know the graph's really small, but I wanted to get it on the page so it's really small. What I'm looking at here is over here on the right, x approaches infinity for the right. That's the extreme right side of the graph. Now, a little bit disclaimer, my graph there, and you can't really see it, it's only going to 4, But what I mean by extreme right side, use your imagination on and on forever. My graph goes to 4 and stops. That's hardly extreme. But use your imagination, and on the extreme right side of the graph, it approaches y equals 0. And the same thing over here. As x approaches negative infinity, extreme left side of graph, it approaches y equals 0. So the point here is that limits at infinity are talking about the extreme left and the extreme right sides of the graph. And just like all other limits when we look at graphs, your limit answer is your y coordinate. And this will be where we end this recording.